Hello class, for today I'm going to show you the quiz review, and I would like you guys to work on an assignment with 4 questions in it. Most likely your quiz will be just about permutations like how you see on the review. After this video, please go take a look at the review and then see how you solve permutation questions. So we will have a couple of slides to go over here, and I would like you to take down some notes, and if you guys want to pause the video at any moment and try these questions on your own, that'll be fine as well. Alright, so let's take a look at number 14, 15, and 16 and see how we can do these types of problems. Now, there will be same types of context, but with a little different twists. So we're gonna have 5 questions, and each question is 4 choices, and 5 questions, 4 choices, same thing. But the every single time there's a little condition after that. But first, let's start with 14. A multiple choice is 5 questions. Okay, so it's 1, 2, 3, 4, 5, and each question is 4 choices. How many ways are there to answer the questions? So if you were to guess 5 questions that has 4 choices in it, how many ways in which can you do this? Well, because question 1, 2, 3, 4, 5, all that matters, the way that you answer these questions, there are going to be 4 choices for each of them. 3, 4, 5. And so it's really just going to be 4 times 4 times 4 times 4 times 4, which if you typed it in your calculator, I believe what you're going to get is 1,024 ways. Okay, so that is regular standard way to answer 5 questions and has 4 answer choices. Number 15 says a multiple choice test has 5 questions and each question has 4 choices. How many ways are there to answer the questions if you know the answer to the first question? So if you draw those 5 blanks again, what should you put in the first blank? You already know one answer to these 5 questions, and you always know that assuming that you will try to get the question right, you will only put down that one answer choice down. So which means the rest of it will be 4s. So it'll be 4 times 4 times 4 times 4 times 1. So that's 256 ways. And the last question here says a multiple choice test has 5 questions. Each question is 4 choices. How many ways are there to answer the questions if you know the answer to the first 2 questions? Well, pretty much the same thing, right? 1, 1, 4, 4, 4. And so the answer should be 64 ways. Pretty simple. So for homework, if you get these kind of questions where I give you small changes in it, make sure you draw the blanks, know how to draw the blanks, and fill those numbers up and see how you get the answers there. And then we also talked about how to rearranging seats. Remember, when you're rearranging seats, passwords, and picking, out of student council members, which I will go over also, like president, vice president, secretary, like the positions are specified. All of these will involve permutations. That's what I want you to remember. It will always involve permutations. So seating 8 students in 8 seats in the front row, well, that's 8p8. If you remember the formula, that will be 8 factorial over 8 minus 8 factorial. So then that would just be 8 factorial over 0 factorial. Remember, 0 factorial is just 1. So if you type in 8 factorial in the calculator, you should get 40,320. Or you can do 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. It's up to you. But there should be a factorial button under the calculator as well. Now let's say that seating 8 students in 8 seats, but then there needs to be specific order. So for example, like I want Daniel to be in the middle, or something like that. That means I have to draw those 8 blanks. I'm sorry, I can't make it to be in the middle. Let's say Carl and Daniel have to be in the middle. So what I can do then is that these 2 middle numbers have to be Carl and Daniel, right? So there's only 2 people. So I have to make it like 2 times 1. Like Daniel, Carl, Carl, Daniel. Like, so there could be 2 ways in which I could rearrange these 2 people in these 2 seats. So we prioritize these. If there's any prioritizations, you want to consider them first, and then put the numbers in accordingly afterwards. So after those two people are done, that would be 6, 5, 4, 3, 2, 1, because there would be 6 people arranged in these 1, 2, 3, 4, 5, 6 leftover seats. Okay. Okay, so the newspaper question. This will involve the editor, seat, specific positions at a given group of people. So we have a editor-in-chief and assistant editor-in-chief. The staff of the newspaper has 12 students, so we're choosing 12. Out of these 12 people, we're specifically looking at these two categories and go, okay, I want to choose 2 out of these 12 people to be specifically in those order. So this is not combination, this is a permutation question. In how many ways can students be chosen for these two positions? So there will be n factorial over n minus r factorial, or we could just type in 12p2 into the calculator, but just for the sake that you do not have that function, you're going to have this, but that will be 12 times 10, 11 times 10 times, well, that will be 10 factorial, right? Because that's 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. That will be 10 factorial, so these two would cancel. So my final answer is 12 times 11, which I believe it gives you 132. Okay. Last question for the day. How many unique passwords can be made from 4 letters if repeat letters are possible? So if I create a second context of the question, if repeat letters are not possible, then what to do for these two types of questions? Well, here we have 4 letters, now passwords that could involve 4 alphabets, and letters are 26, numbers are 10, because it's from 0 to 9, which is 10. So if I know that these all 4 have to be letters, that means that the first one, there will be 26 possibilities. Second, third, and fourth will all have 26 possibilities, which means it's going to be 26 to the 4th power. If you do that under the calculator, you will get 4, 5, 6, 9, 7, 6. So this, you cannot be using the NPR part, like the permutation formula. You will have to draw in the blanks and fill in accordingly. Now, what if it's not possible? Well, then you will still draw 4 blanks, but it will be 26, 25, 24, and 23, because each of these have to be unique letters. So 26 times 25 times 24 times 23 gives you 358800. Now, what if they say, how many unique passwords can be made from 4 letters if repeat letters are possible and first 2 letters have to be vowel? So what about in that condition? Like what would I have to do? So think about this question for me, and then pause the video now and see if you can do this one. So if the first 2 letters have to be vowels, that means that if I were to draw 4 blanks like this, the first 2 have to be either A, E, I, O, U, a selection of 5 letters. And since the repeat letters are possible, I can say 5, 5, 26, then 26. Because these 2 have to be vowels and these 2 can be anything. It could still be vowels, but the first 2 have to be vowel. That means that that's the condition that I need to prioritize. So that would be 25 times 26 times 26, which would mean that would be 16900. In other words, if we want to make sure that the first 2 letters have to be a vowel, then it should be this. If I want to make it so that the last 2 are not vowels, if they're not vowels, that means it's going to be 5, 5 for the first 2 vowels, and then I have to do 21 and 21 because these are the amount of letters that are not vowels. So in these so many different types of contexts I could make it, you just need to be prepared as to what to prioritize and put the numbers accordingly so that you get the correct answer. Okay. Hope this video helped, and on the homework page you will get 4 questions that deals with the same context, and you need to fill in the blanks correctly and multiply them through and get the correct answer here. And then make sure you guys always multiplying those possibilities to find the final permutations of the ways in which something could happen. Okay, so make sure you understand the three different ways it happens. It's always rearranging seats, or front row seats or books, rearranging books, password codes, and student council, getting them into a group of editor and chief and editor, vice editor, whatever. If the positions are specified, you always use permutations, and those three are the main ways that you'll be encountering. Okay, and have a good day.